welcome to this video on the topic of exponential functions. In this video, we're going to have a look at how we can use our calculators to aid us in the analysis of exponential functions as well as the solving of exponential equations. Now for this video, it's been split into three sections. For sections 1 and 2, we're going to use our calculators in graph mode and have a look at how we can extrapolate values from a graph. For part 3, we're going to have a look at how we can use our calculators to solve equations containing single unknowns in an exponential equation. Now looking at parts 1 and 2, we're going to be referring to an example involving a colony of roaches. The graph below represents the population of a colony of roaches. The vertical axis represents the colony size, shown over here, and the x-axis represents the days since the colony started, shown over here. So in place of C we have Y, in place of Y we have C, and in place of X we have T. In part 1, the colony size may be evaluated by observing the value of C for given values of T. So determine the colony size on day 3, 7, and 20. Now to enter this question we need to bring up our calculators and go into graphing mode. So we go menu, and then we go 5 for graph. Next thing we need to do is we need to key in the function that describes this curve. In our case we're given it and it is c equals 2 times 1.22 to the power of t. Now in the case of this calculator, whenever I see t, I'm simply going to put in x. The difference between t and x is purely cosmetic in that we're not going to get any differences in the values that the calculator spits out. Now next thing we do is we graph it by clicking F6. What you'll see over here is your calculator could give you any number of results. Most likely is that the calculator is not going to give you the result you intend. Rather, what we first need to do is set up our viewing window, or set up the location of what we'd like to observe on our graph. To do this, I'm going to click F3 for V window. After this, there are 5 quantities that we need to change. Now what we're looking at in the first quantities are the span of the x-axis we want to look at. Now this is purely contextual and it's going to change on every problem. Now for this problem we're looking at the time between 0 and 25 roughly, or we're looking at the colony behavior from day 0 upwards to about at least day 20 as shown here. So I'm going to put in, say, 23. Going down, we have ymin and ymax. So this tells us how much we want to see on our y-axis. Now again, we can simply extrapolate this from our graph, or we can sort of estimate. We know for a fact that the colony size is going to begin at least 2 cockroaches, but we're not sure how high it's going to go to. For this instance, we could guess something really high and then adapt later, or we can just look at our graph. For this one, I'll go 200. Sometimes we may change this so we can see features more clearly on our calculators. Once that's done, we go exit and we'll graph. And thus we have our beautiful graph shown here. Now, the next thing we need to do is start pulling values off this graph. To do this, I'm going to go to gsolve, so F5, F6 to go across, and then we're going to use ycal. Ycal is going to allow us to enter in a value of x, and it's going to tell us the value of y. Or in our case, we put in the day and it will tell us the population count. For day 3, it's going to give us a value of y equals 3.631696, but we need to use context here. On day 3, there are 3.6 cockroaches. We don't have part of a cockroach, we have a whole cockroach. So on day 3, we're going to have 3 cockroaches. So I say using calc, C equals 3.6, so therefore there are 3 roaches. Doing the same for 7 and 20, gsolve, across 1, ycal, 7. We can see there are 8.045 or 8.0, therefore there are 8 cockroaches. And then going down, on day 20, we have 106.7. Notice how with this example I'm not rounding up, rather I'm simply truncating the answer, or let's say rounding down. The reason for this is that we're going for a guarantee. At the start of day 3, there's roughly 3.6. So that means there's not 4, but there's always guaranteed to be 3. So we just say there are 3 roaches. Perhaps there's still roaches in the eggs. But basically, what we're doing here is not only are we extrapolating the answer, we're also inferring some context from what was given in the problem. So this is what would be expected if you were doing a problem like this. Going down to part 2, we're doing the opposite to part 1. Rather than pulling values off the z-axis, or the vertical, or the y, we're now going to pull values off our x-axis, also known as our t-axis in this example. For example 2, determine what days the colony will be at least 4 roaches in size. Now for this one, we're going to go to gsolve, cross one. Rather than ycal, we're going for xcal this time. Xcal is going to ask us, give me a value on the y-axis, and I'll tell you the value on the x-axis. So I'll put in 4. Now, annoyingly, what has happened is it's given me a value, but it's blocked by the cursor. So I'm going to change my V window so it doesn't get in the way. Go down and I'll change it to at least 5. Running this again, I'm going to go day 4, and now the cursor's out of the way. So when we have a roach population of 4, we're going to be on day 3.485, or let's say 3.5. So we're going to say t equals 3.5. Alright, and then to finish it off, I'll say during day 3. So determine on what days the colony will have at least 4 roaches in size. Using calc, we found that it was on 3.5, so it happened during day 3. So we say during day 3. Part B, have at most 39 roaches. So again, we'll change our V window back to 25, graph it, and then we'll solve for 39. Alright, so this occurs on day 14.937. So what we get is that when the cockroach population is 39, it's on day 14. So the question is, determine on what days the colony will have at most 39 roaches. So that's inclusive of all days before day 15. Alright, next one, we have b over 9,000. So we bring up our calculators, we go to gsolve, and then we hope we can fit up to 9,000 on here. So 9,000, and it's not found. So what this is suggestive of is that we need to raise our window a bit further. So we don't want to go to 0 to 200, we want to go to at least 9,000. Go 9,001, solve, and it's off the window. So we need to raise our V window further. So it's our x-axis that needs to go up. So we'll go to day 100, and thus we can easily see it. Modifying the V window again, we'll go to 50. So it's a bit of guess and check, and that's good enough. Now we'll go gsolve, xcal 9,000. And what you can see is that the roach population will reach 9,000 on day 42. So to be over 9,000, we need to get to day 42. 42.3. So it's going to happen on day 42. So it's going to go over 9,000. So that's how we'd get values on values for our horizontal axis when we're given values on our vertical. This one here being a bit contentious in that we have to modify our V window. Now, part 3, we're looking at how we can solve exponential equations using our calculators. Now, this might be pretty hard if we did this algebraically, but lucky for us, we've got our calculators to help us. The way in which we use our calculators to solve these is we go menu, click on 1 for run matrix, and then we're going to go into a few layers of our calculators. We have to go option, calc, then F1 for solve. If we're going for a single solution, we go for solve. If we're expecting more than one answer, we go for solve n. In our case, we're going for solve. After that, I'm going to put in the equation 64, shift down to equals. Then we're going to go 4 times 2 to the power of x. Now we might be tempted to just hit execute, but that will give us syntax error. What we need to do is we need to tell the calculator what we're solving for. So we go for comma, then we write x. Then we close off the brackets. Hitting solve, we give a value of 4. So to show what we did, we say using calc, and we say therefore x is equal to 4. Now this is a valid solution, provided that the question only says solve. If it says show algebraically, then you must show it algebraically, but for these questions in stage 1 general mathematics, all you need to do is use calc to solve these. Moving across, let's go for the next one. Go to the top menu, option, calc, solve, 10 shift equals 2 times 3 to the power of x. We are solving for x. The answer is 1.465. Lucky last. Solve negative 55. Shift equals negative 13 times 0.25 to the power of x. We are solving for x yet again. Thus our answer is negative 1.04. And thus we solve our exponential equations using our technology here. Now in summary, what we had a look at in this video was, firstly, we had a look at how we can use our technology, so our calculators, to be able to extrapolate values of y given values of x. We then had a look at how we can extrapolate values of x given values of y, so shown over here. We also had a look at how we can graph exponentials in our calculators and set up our V window. And then finally we had a look at how we can solve equations involving exponentials using our calculators.